right? So you intuitively know that if you are, when you are playing a baseball, right, to throw the ball, to increase its speed from 0 to whatever is the speed with which you are throwing the ball, you are applying the force on it with your hand. You're exerting the force, and that force is changing the speed of the baseball. In the same way, when you are catching the ball, right, it arrives at your hand with certain speed, and you want to reduce it to 0. You then apply the force in the direction opposite to its direction of motion to slow it down. Right? So to change the speed, either increase it or decrease it, you need to apply the force. But at the same time, in order to change the direction of motion of an object, you need to apply a force. And let me show that. Okay, when you are whirling around an object tied to a string, right, which you hold in one hand, what is happening, even if the object is moving along the circular path with a constant speed, that is, it's the distance it covers in the unit time is always the same. Nevertheless, what is happening, you are changing the direction of motion of the ball, right? At this instant here, it has a tendency to go this way. At this instance here, it has a tendency to go this way. And to change the direction of motion, you need to apply the force in perpendicular direction. What would happen if you let go? The object would fly off in tangential direction. Right? If I would let go here, so that there is no force on this object forcing it to change the direction of motion, it would simply continue moving along the line tangential to the point on the circle where the force was released. Okay? So we need the force to change the direction, to change the speed, either increase it or decrease it, or to change the direction of motion. In the case of motion along the circle, the force has to point towards the center of the circle. Now, what he came up with is not intuitive at all from our everyday experience, right? If I'm to move something large, say I want to move this chair. In this example here, I have a chair, right? And to make it move in this direction with constant speed, I need to push it with my hand. But that push is not the only force. If this was the only force acting on the chair would be accelerating in this direction. That is, its speed would be increasing. But there is other force. There is a force of friction at the legs of this chair. So that in this case here, the net force is 0. When I sum up the force pushing by hand in one way and subtract from it the forces of friction, I would get 0, and as a result, the speed with which the chair is moving is constant. It's not accelerating. So net force is equal to 0. And hence no change in speed. So it's tricky. It's not very intuitive. If I would take a wax and cover the floor with it, then I would realize that the amount of force that I need to apply in order to push the chair with the constant speed becomes less and less because the friction is reduced, right? So in that case, in the case of 0 friction, I could give chair initial shove and it would just be flying on the floor just like a puck on the ice sheet, right? Because the surface of ice has relatively low friction. So when you hit the puck, it moves quite a distance because the force of friction is low. So his laws of motion are not very intuitive. Nevertheless, they are correct, and this is their essence. So again, in order to change the speed of an object, either increase it or decrease it, or to change the direction of motion, you need to apply the force. If there is no net force, like in this case here, then the object moves with a constant speed, or in particular case of constant speed, it's at rest.